is the next video in the video series. This is the first video regarding fabricating the rear engine mounts or the front transmission mounts, whatever you want to call them, to get the LT4 bolted into the chassis. So what I have here is, this is the custom transaxle plate that comes with the Superlite car. I covered this in the engine video. Essentially what this piece does is it mates the LT4 Chevy engine or GM engine to an Audi/Lamborghini rear engine transaxle. So this plate bolts to the engine and then it bolts to the transaxle, but it also bolts to the frame to provide some support for the front of the transaxle and the rear of the engine. And it does that by these brackets. These are the rear engine mount brackets that come with the car. And they're, beautifully made. I mean, 1/4-inch steel, they're zinc plated, they're notched, and then plated from the back. Unfortunately though, I have to fab up custom brackets, and I'll really explain why. This transaxle plate is for the LT4 engine, and these plates will actually secure the engine in the chassis. The problem is twofold. One, it mounts the engine probably about 1/3 of an inch too low for me. This is a race car. I mentioned before I'm interested in making a street car, and New Jersey law dictates that nothing can sort of drop below the frame rails. So if I use the engine in the stock location, which is a lower center of gravity, the bottom of that engine just sort of peaks below the frame rails. And I don't want to complete the car and then go to the inspection station and fail inspection. Then I have to rebuild all these engine mounts. So I can't use these engine mounts because of that. And also I've shifted the engine back 1.5 inches so that I can fit that air intake elbow on, and I'd have to modify these in order to do that. So anyway, that's what we're going to talk about in this video. But this is the plate, and actually if you watch B for Build, they're using a very similar plate made by race car replicas to bolt a LS3 into a Hurricane Lamborghini chassis. So it's pretty cool. They're using the same parts. Now they've been able to put that engine in about a day, where I've been working on my build for about 6 months, just working on the custom work necessary to mount the engine. But I do it part-time, and also I'm a beginner, so I'm going slow and steady. Okay, so I'm going to segue over to my thought process with regard to making these brackets. Okay, so before I started working on the car, I ordered the car. It took about 9 months for it to be delivered, and during that time I put together a build plan, and I anticipated shifting the engine back a bit. And what I simply thought I would do is, for each one of these rear engine brackets, I would put in a steel spacer. This is a piece of plastic, but for demonstration purposes, I would literally extend the bracket out 1.5 inches. The transaxle plate would be where my fingers are, and then I would bolt this up. And I thought that would be a great solution. It may provide a little torque, on this sort of thin section of the bracket, but I felt that would work okay, considering I have a sturdy front engine mount and then a sturdy rear transmission mount. The problem is on the LT4 engine, there's a water to oil cooler on the lower driver's side part of the engine, and it actually interferes with where the bolt would go. So I literally have to get the bracket closer to that transaxle plate. So then I figured, okay, well, maybe I just extend this bracket, pretty simply, and take a piece of steel. This is cardboard, but I love mocking things up. And then I would simply have the welder weld this in. And because these brackets were a little too low, I would weld in these holes, and then I'd re-drill them in the proper place. and then I would just mount these to the chassis. The problem is, and you'll see this in a little bit when I segue over to the brackets mounted in the car, there's a TIG welding ridge right about here on the chassis, and it would interfere. So if I welded this flat, I'd have to put some sort of spacer between the bracket and the frame, which I just didn't want to do. Okay, and it may not be that aesthetically pleasing to have this welded up, you know, a little bit of a Frankenstein look. So, you know, this is the design I came up with. And here are my prototype brackets. So these are just simply made out of plywood. I love using plywood. But essentially, I came up with this idea of using two 45-degree angles to get essentially 1.5 inches more worth of travel or worth of extension to move that engine back. And then this particular area will clear the frame where the TIG weld bead is. I'm going to have somebody fab this up. I cannot bend 1/4-inch steel here at the house, but I have somebody that's going to do it, and I'll drop this off probably next week, and they'll start working on the brackets. Okay, so this looks like a really simple end result, but I will tell you the hours I've put into, you know, sort of figuring out how high the engine needed to be. Also, whether I could leverage or reuse this bracket or come up with a design that somebody could actually make. You know, I sort of learned my lesson from that intake elbow. If you come up with a design that's too complicated, you know, you just can't make it without a tremendous amount of time. So I've checked with the fabricator. He said he could fab this up, no problem. So I'm looking forward to having him make this. Okay, now we're going to segue to the back of the chassis, and you'll see where these are located with regard to the frame and also the transaxle plate. Okay, here we go. So here are the plywood prototype brackets. Temporarily mounted in the car. I mean, I mounted them with just some plastic clamps, but you can see how they'll be positioned, and I'll zoom in a little bit so you can see the passenger side mount. Fits in there really nice, and you know, the identical thing for the driver's side mount. You know, the idea behind this design, as I mentioned before, you see that TIG bead. So by angling using a dual 45-degree angle and not extending that plate straight and doing a longer 90-degree, I clear that bead. And I also get, you know, if I zoom out here a little bit, you know, I get a little extra room to run the exhaust. You know, the exhaust is pretty tight. I mean, you know, there's the bottom of the manifold, and we'll basically bring the exhaust down and then curve around. Then through here, I want to put a small catalytic and then resonator and then muffler. If I can jam it all in there, I'm not sure. But anyway, that's what the prototype brackets look like. This is a top view. I'm not going to bother drilling the holes now. I'll send these off to get fabricated. You know, I can't bend 1/4-inch steel here. And then I'll drill the holes and fit it. I'll get the top of the front engine mount, the caps. You know, here's a picture of the caps. I'll get those welded on, and then I'll send them both to the plate, or I'll get it nickel plated, and then we'll move on with the build. Okay, so the next video will show probably all this stuff fabricated and plated, and the engine, you know, the engine and the chassis. Then after that, I'll work on the alternator bracket, and then we're pretty much done with putting the engine in the car, and I'll move on to, you know, something different, mainly the power steering. Okay, thanks, bye.